So this is my talk, Awaiting the Future. I'm Paul Evans, as it says here. So what I'm going to talk about is a bit of an overview about what futures are. I'm going to try not to make it a big, long lesson. This is just kind of an introduction to make the rest of the talk make sense. The rest of the talk is looking at what a lot of other languages are doing with futures at the moment, because I want to steal something from them, namely a bit of exciting syntax that I want to put into Perl. So, first of all, what's a future? It's a useful building block for... I can't see my slide, hang on. Let's make this bigger. One moment. It's all in German. Oh dear, that doesn't help. This is the problem with borrowing a laptop at the last minute. I'm going to have to keep staring up there because I can't see this one, never mind. So they are a useful building block for doing asynchronous single-threaded code. I'm going to try and fiddle with the laptop, I'll just let them do that. Which seems to be a thing that lots of people want to do lately. I've talked a lot more about futures at this talk, Asynchronous Programming and Futures, at YAPC U2015. Oh no, there's an error on the slide. I did it at this place. That slide is wrong, never mind. Yes, I think I did. Yeah, I think it was 2015. No, it was 2014. I'm wearing the wrong t-shirt today. Never mind. I knew I checked the slide was right. I forgot to check my t-shirt. Never mind. Never mind. Can't. So I'm going to keep going back to this example. So I'm going to talk about this for a while. This is a kind of typical future-ish problem. First of all, just written with LWP, which is not asynchronous. Do I get a laser pointer from you? Is there like a... Yes. That one. Oh, that's exciting. Right. So this is just using LWP user agent. And the idea is we're going to fetch 3 different pages. And for arbitrary reasons, we are going to sum the content length of all these 3 pages and work out how long in total these 3 pages are. So here's a nice little program that will do it synchronously by just fetching the first page, then fetching the second page, fetching the third page, add them all up. It works, but it's not very efficient because while we're waiting for this page to come back, we're not doing anything else. And maybe this is quite a slow server. It might take a little while to answer. It would be nice if we could send out all those 3 queries, wait for the server to answer all 3 of them at once, and collect up all the results. Because then overall, we'd get our answer quicker. And this is kind of the point of a lot of asynchronous programming, is to try to combine multiple things at once so that you can wait for lots of things, rather than just wait for one thing repeatedly in sequence. But it's neat, because each of these functions kind of returns its result. So you can just read the program, ignoring the inefficiencies. You can just read it through. You can say, well, look, R1 is the result of doing this thing, R2 is the result of doing this thing. It kind of reads nicely. So functions return results, but we have to wait until that result arrives. Really inefficient. And it leads to what we call a lot of dead time, where basically you're kind of waiting for something, and then you're waiting for something else. Lots of waiting going on. So people started applying callbacks to these things. So rather than waiting, you pass in this little function here, and you say, well, do this at the end of the request once you've got the response. And this kind of works fine for one thing. And then down here, we can go off and do something else. But how do we wait for all 3 at once? It's rather messy. And this is the slide I wrote for EU 2014, 15, whichever one it was. And I won't go into long detail now, but it's kind of a bit messy. You kind of remember when you've got the results, and then every time you get another result, you see, have you got all of them? And if so, then you can kind of do the end. And it's very messy because a lot of this is all the machinery, the low-level machinery of how do we wait for all 3 answers. And it's not really related to the problem. There's a lot of noise in here. And if we're going to do further operations after that, it gets even messier because you start nesting all these callbacks and they sort of march further in from the margin. It gets even worse. If this was like a 10 or 12 stage pipeline, you're kind of marching out sort of in this triangle shape, and it looks basically horrible. So what we find with callbacks is that what we call divergence, i.e. going off and doing multiple things at once, is easy. Trying to converge the results again at the end is hard. And sequencing, it's kind of easy, but it looks messy because it sort of indents further. And that can sometimes cause annoyance where you say have 5 stages of a pipeline, and then between the first and second stage, you think, actually, I just need to do this other operation. Oh, wait, I now have to re-indent 300 lines of code underneath. That's going to annoy my code reviewers, and it's going to make very messy diffs, and if someone else has a branch against that, it's horrible. So you don't want to do that. So what we do is we invent the idea of a future, which is a first-class representation of a future state, the next state that the program will be in at some point. So we have our functions return a kind of a box, a value that says, here is where I'm going to put the result later, but I haven't got the result yet, but I'll tell you when it's there, so that we can return a value. And later on, that value then receives the result when it becomes available. And so because we've now got this value that we can work on, we have this proxy to an operation that is in progress. We have something that we can talk about, which means because we have this value, we can combine multiple values up to make a new value. So that the kind of concept of wait for that thing and that thing and that thing to all be ready is itself an ongoing operation that will at some point be finished. So we have this idea that we can converge by just making another future. And so suddenly convergence looks much simpler. So here's a real piece of code, other than this kind of top line here. So again, this is from the AppCEU, when I invented a lot of these hypothetical modules. And I said, well, I'm not going to tell you how this is implemented, but trust me, it kind of can be. It's boring, I won't go into it. But it serves the point that we have this function called HTTP-GET, and it's going to return this future, which I'm calling $F. It's fairly standard notation. So this thing here is going to start this HTTP operation, and immediately returns this future value. It can go off and do that operation however it wants. And at some point later, the result is going to arrive. And there's multiple ways that we can deal with that. One of the easiest is to call this get method, which kind of defeats the entire point of a future, because what it's going to do is block and wait until the result actually arrives. But it does mean that you can write this code that looks very straight line, like a sort of call return thing, and it's kind of neat and tidy, but obviously it only gets 1 page. Well, how do we get all 3 pages? Well, we have this way of combining futures. Because each of these 3 functions is returning a future immediately and just says, here's a future that at some point in the future will complete. So we can combine all of these features with this fancy needs all constructor. And that returns a new future, because this just represents an operation that is ongoing and going to complete sometime. And now we can wait for that. And exactly how that works inside is kind of immaterial for the point at the moment. But in some way, it's going to wait for all of those 3 to happen. Maybe it's going to be synchronous, maybe it's going to do some kind of async thing. We don't know at this point. It all depends on what HTTP-GET does. Doesn't really matter. The point is, we've expressed our intent here very clearly. We've said, we want all of these things to complete. When they do, give me the result of all of them. And we just get the results as a list. And now we can just sum the content length as before. So that starts to look very similar in structure to the first kind of straight line neat code. But suddenly we can do this asynchronous 3 things at once. So we've got our efficiency back. So that's quite nice. And just as a kind of a brief aside, there's really nothing magical about the future. It basically is just a box that represents a callback upside down. So rather than the caller passing in the code to say, do this when you have the result, the function returns the box to say, I will put the result in here at some point later, and you just have to watch that box. It doesn't know about event loops or anything, the abstract concept of a future. The way you actually implement a function for real that might actually return a future has to do something to work out how it's going to be asynchronous inside. But that's the kind of the lowest level implementation detail. And all the rest of the wrapping above is just working with these kind of inside-out callback boxes. I'd say it's an inside-out callback. The particular implementation of future is basically just a list of code refs. So when you want to observe a future, you can stick code refs in it to say, run this when you get the result, and then at some point the result will arrive. It will also store the result once it's got the result, in case, for some reason, the future is actually already completed. And you say, oh, I want to know when that finishes. It says, oh, well, it's already done, because here's your result. So it's a little bit neater than trying to do a callback thing as well, because it will remember the result. And there's some kind of fancy tricks you can do that sometimes. It's quite useful. But in summary, a lot of the operations on a future start to get a bit messy sometimes. You can turn futures into other ones. We've already seen needs all. There's a few other combinations, like you can wait for any one of them to complete, and there are variations on how to deal with errors, because futures can fail as well as succeed. I won't really go into that in much detail, but there are ways that you can decide if some of these fail, do you still want to try and do the rest, or do you just want to pull the whole thing off, whatever. There's a then sequencing as well, which is quite neat. So because HTTP GET returns a future, the concept of when this future completes, do this other thing that returns a future, that entire concept is just an ongoing operation, right? That sounds like the sort of thing you can represent as a future. So you have this chaining operation called then, which says, do this first thing, then do a bunch more code and wait for the second thing, and the result of this operation is itself a future. So we can do these sequencing operations a lot neater than that kind of pyramid shape of nested callbacks, because these are just chained below. So suddenly you don't have to keep indenting your code further and further. How we do? Excellent. So yeah, another thing you can do with a future, as I say, is an operation sometimes called forcing. So you call get on it. Sometimes it's called force. It's a blocking wait, so it's going to pause and wait for the result to arrive, which means it's kind of rude to do that anywhere in the middle of a module, for example. Like if you're going to call get, you've kind of obviated the entire point of using a future, because now you're blocking waiting for the result. So it's kind of rude to do it, but it's a very handy thing to do in a top-level program. For example, you might decide to write your entire program as a little module that just returns a future, and then obviously at the top-level main here, it's not really rude to call get, because literally your program isn't doing anything else. This is your entire program, so you might as well just wait for the thing. So get is often useful there, but it tends not to come up really anywhere else. So more or less everything else you write tends to be things like then chain. The third way that you tend to try and use futures in larger programs is you need to back them by some kind of event loop. And then there are some extra little hacks and methods on futures to make using them in event loops a bit nicer. So if you have something that keeps a reference to the future and makes sure that as an object it's still running, you can attach callbacks onto it to say, when you're finished, run this callback. You have to be a bit careful not to end up going into the kind of callback mess that you ended with, that you were trying to avoid with futures in the first place. But it generally works okay. One kind of problem that we still have with just futures, though, is that if you have a long sequence, then let's get to the code already, and I'll talk about it. So if you have this long sequence of then blocks, each one is its own lexical scope that can't see the other ones before it. And so this is kind of a problem that we've made by not having nested callbacks. Because if you have nested callbacks, each one can see all of the variables in its parents. So even though the code looks messy and indented, it can at least see all the variables. But we have this kind of problem here. So suppose we want to fetch a page, and then we decide we're going to fetch its style sheet. And now we've got style sheet down here. We can't see this page variable anymore because it was hidden inside this bit of code here. We literally can't see it. And so if you want to solve that kind of problem, you start having to just hoist the variable out like that. And it's a little bit messy. It kind of works, but we'd prefer not to.
Wouldn't that be a problem with the asynchronous nature, that $page might be not what you think of in the then?
But then not going to get called
no, because
the previous one is run.
Because I mean, we have to. So obviously, this is
assuming you have multiple gets, is what I'm saying.
Yeah. So presuming this is wrapped in a function. If you were to call this function, say 5 times, for 5 different pages, each function has its own $page variable, and so when you capture it down here, you're referring to the right one. So Perl will handle that for you itself. It works. It's just a bit messy because it's not too bad in this example because we've got what 8 or so lines here. But if that was like 50 lines long and we had 20 or 30 different variables, I mean, it's not really a nice way to write code. I haven't got an example on here because they're even more complicated, but things like while loops and for each loops, if you want to start asynchronously waiting for something in the middle of a for each loop, they get messier still. The future distribution on CPAN has a module called Future Utils, which tries to provide some helpers to make things like for each loops and whatever a little bit neater. It can help, but it still means that you're writing code that looks very different to a for each or a while loop or whatever. It's just in straight line code. It looks quite a bit different. So we now get on to the bit where I said we're going to look at some other languages. So it turns out that a number of other languages, well, I say three, but there's more than three, but the three main other languages have kind of converged on a syntax that helps a lot of these problems and makes all of this even neater again. They are C# as of version 5, ECMAScript version 6, otherwise known as JavaScript, and Python 3, not Python 2. So I'm now going to put up some non-Perl code on the board. And even Rust actually lately. I didn't put out an example because they haven't converged on exact details yet because they're Rust and they're going to spend ages debating the finer points. But they've decided that this is a nice idea and they're going to start thinking about it. So these are four quite different, quite diverse languages, and they've all come to the same conclusion that the same style of syntax is nice, and it's looking like it could eventually become this sort of universal idea, along with things like a while loop and an if statement. I mean, if you think of what while loops and if statements look like across these four languages, they're identical, right? And this syntax is looking identical across them. This is a nice idea. So what does it look like? In C# 5, it's a typed language. Everything has a type, and there's a type called task, and it also exists as a generic form, task brackets t. And what that means is here is a task that is going to return some value of type t. So here is an example from drmicrosoft.com, and this is, I kind of trimmed the example, deleted a bunch of comments and so on, but this is basically their code. So here we have a function that calls an HTTP. Everyone uses HTTP as future examples because it just kind of makes sense. So they download this random page with this HTTP client. They get the result back. They call a regex on it, and they count the number of times .NET appears in. So that's it's not exactly the same as our example, but it's kind of similar. And principally, we have these two new keywords, async and await. Async is a little sort of annotation on the function itself, and await kind of appears as this little expression in the middle. What does ES6 do? Well, in ES6 there's a type called a promise, which is basically the same as a future. They just picked a different name because there are multiple names for these things, but they have a thing called a promise. And again, this is an example from their documentation. There's links in the slides. There'll be a link to these slides in the end, so don't worry about this link. But exactly the same syntax. We have this word async. For some reason, they put it before the word function rather than after, but never mind. Async function, again, exact same C#, and you have this await expression in the middle that can wait for these results. And this is quite a nice example of some parallelism going on, where you have this function called resolve after 2 seconds, and in their example, they defined it up here, but it was about 8 lines long. I didn't bother to put it on the slide. That is a function that returns a promise that we store in this variable called a, that in 2 seconds' time is going to return the number 20. But of course, this function here just returns a promise, so it returns straight away. So we call this other one, var b equals resolve after 2 seconds 30. Does the same thing, returns immediately a thing that's going to wait and eventually return 30. And then they do this little example where they kind of return the sum of them and then they print it on the console. And you run this program and you find that after 2 seconds it prints the number 60. Because it only had to wait 2 seconds, because it can do this wait concurrently here. It's got this one thing that's waiting on, this other thing that's waiting on. They're both going to return after 2 seconds. So these awaits here, after 2 seconds, they're both going to wake up and have the result. Then we go to Python 3. Python 3 has a type that's named the right thing. They called it. It's bizarre actually. A lot of the Python 3 async IO stuff looks very similar to my async. A lot of the method names are very similar. I think somebody may have got some inspiration from multiple places, partly mine, and because the naming is all really similar. So anyway, so they have this thing called a future, and again from their documentation on a page called tasks and coroutines, they have actually have these two functions, but never mind. So again, the word async appears at the beginning of the function definition, and inside it there's this keyword await. Now this one here is just waiting and doesn't return a result. But that's basically waiting, that's kind of an async sleep, it's just waiting for a second, returning a result. And this one here is then waiting for that one and prints a result. So this isn't actually a very exciting example, but it shows off the syntax just as well. So what we have here in all three cases is this keyword async. And the keyword async it marks a function itself to say this function returns a future promise task thing, whatever. It somehow acts in some kind of deferred nature. And principally what that does is alters the return type of the function to say it must return a future promise thing, whatever. But by doing that, you allow the use of an await expression somewhere inside the function. And it's this await expression that is really the core of what makes this nice. Because what await does is kind of just, it's a bit like calling get on the future. Except that because it knows the containing function has to return a future, it knows that if that future isn't the future that it is trying to wait on isn't ready yet, it can cause the whole containing function to just return a pending future and say, no, I'm not ready yet, the caller can carry on. Knowing that later on, it can wake up, carry on where it left off, and then eventually that returned future can have its result, and then eventually the caller will see that result. So it's kind of like putting a then, if I just go back a minute, it's kind of like putting a then call in here. That's sort of what that looks like. But rather than having then and then nesting an entire subfunction in here that is different to the outer function, we're just kind of stopping this function and then carrying on again later on. So it is the same function that resumes later on. And that has a lot of power to it because, well, I'll get to in a bit. The key thing to really observe about async await is that it happens entirely on a per function basis, right? So it suspends and resumes one function, one on its own, and it builds on top of already existing futures. So we can do this in Perl, because we can kind of do all these things in Perl, right? I mean, the whole idea of something that works on a per function basis, that's kind of lexically scoping things. I mean, that's kind of what Perl's all about, right? You want to keep your effects kind of nicely local. We build on top of future type, well, we already have a future type. Spelling and resuming a running function, turns out that's not quite so easy, but there's some hacks you can do to make it work. But we need some custom syntax. So, as of Perl 5.14, we have this fancy keyword hook. Damien talked a bit about that yesterday, but he did a very weird implementation, and I don't like it for a number of reasons. But anyway, we have these keyword hooks. Primarily they allow XS code to implement new keywords. Damien was using a module called keyword simple, which, okay, I don't know if he's in, oh yeah, there he is, which allows you to access kind of a subset of what you could do from pure Perl. So it makes it easy to write the things in pure Perl, but it means that you can only do things that pure Perl could do. And in particular, keyword simple, you parse some Perl code as a string, and then you return some more Perl code as a string. So all it can do is rewrite bits of source code into other things that you could have written yourself. Whereas if you go down at XS, you can actually provide new keywords with new semantics. You can literally add semantics to the Perl interpreter. You can make it do things it couldn't do, like async await. Now, I did a talk about custom keyword plugins at LPW last year. I haven't put a link into the video yet because that's not online yet, but hopefully it will be online at some point, and I'll edit these slides and I'll put a link in there for you in case you want to read more about that. So, back to our how long are these 3 pages example. So, all of this is real code you can run right now, other than this hypothetical thing. You can implement that function in about 5 lines of code, but I couldn't be bothered to squeeze it in here. So again, we have these async and await keywords, and this module here is a syntax hook that kind of builds into the interpreter and adjusts the way that the parser is going to parse these things, and actually adds a whole new set of internal ops to make them work. And so this code basically works the same as any of the previous language examples. So we have this async submain, so that means it's going to return a future. So it starts up, it calls these three gets, and they all return futures, and we wrap them in this future needs all, and likely this future isn't ready yet. So the await expression goes, oh, it's not ready yet. I'll just cause my containing function to return a pending future. So that just returns. And in fact, all we do here is we call get on it, so we're going to force it anyway. But if this was part of a larger program, then all we've got here is a function that looks like a function that returns a future, like anything you could do now. But we can write it in this neater way, because rather than having to attach this into a then block and do something else, we can just carry on in the same function, and we can just get at all the same variables we have. So that's quite nice. So already, one of the things that we see we can do, do you remember the page example earlier? We had to hoist the page variable outside of all the then chaining because we couldn't see it. Well, we don't have this problem anymore, because after this await, we wake up and we resume in the same function. So because we can still see the same page variable, we just kind of carry on here. And if you look at that, I mean, if you kind of ignore the await calls and you ignore the fact that these return futures that return a result, that could just look like straight line code without futures, right? And you can kind of ignore those, and you can just read it as is, and you kind of know what's going on here. Except for the fact that if your caller wanted to do other things, they can work around you. And so you've got this ability to be asynchronous without really writing code in a very asynchronous way, just by scattering these keywords around. What other things can we do? Well, another thing that is really quite messy to do with a straight future is have these kind of optional steps. Because if all you've got is then chaining, if you have a stage that's optional, it's going to enter the then block anyway. But if you decided that the if condition didn't hold, then you just have to kind of return a sort of empty future to say, no, I've got nothing to do, carry on, otherwise go off and do your thing. So it's hard to read the if blocks when you write this kind of code with futures and then chaining. Whereas here, it just looks exactly like straight line code again. We await this page, and then we see, does the page actually have a style sheet URL? Because if not, we'll just carry on doing something else. But if it does, we'll await a get on the style sheet, and we can carry on and we can use other things in here. So suddenly, again, this just looks like straight line code. It gets even better, because we can put await in the body of a while loop. So if we're going to follow this entire chain of redirects, we can just have this while loop with an await in the middle. And that, you literally couldn't write that with a then chain, because you don't know how many stages it's going to take. Some languages don't really have a nice implementation for that. The future module, as I said, has future utils, which has a function called repeat. And repeat, you give it a code block and some other code blocks to tell it when it thinks it ought to finish. And you can kind of write the same thing, but you have to write it in entirely different syntax, calling some util functions. So it means that you have to look at the code and you think, oh, well, it looks a bit different. I don't really understand it. I'm going to have to read the documentation. Whereas here, you don't have to bother, because it's literally just a while loop. It looks really neat. So as I said earlier, the advantages, I'm keeping an eye on the time, the advantages of using this syntax are that it is in effect invisible from outside, because any function that we've said async sub on, from the outside, it just looks like a function that you call, and it returns a future. For right now, I mean, you can write functions like that anyway. You can just say this function returns a future, and maybe under the hood it's implemented with async sub. You don't need to know. From the outside, it returns a future. This is fine. It's also visible on the other way, on the inside. Await just wants an expression that happens to be a future, right? Now, a lot of these earlier examples are await function that I know returns a future, or await future arrow needs all, or something like that, which again we know is a future. But for example, you could just call await and then some function that earlier you declared as async sub, because you know that an async sub function is always going to return a future, so you can await on that. So these two keywords work very, very well together, but neither of them really requires the other one. And they're all, again, very scoped to just one function. So what that means is you can apply it very incrementally. If you have some code that may just be on straight futures and you decide, well, I can make this one function look a bit neater by rewriting it here. I don't need to rewrite my entire code base. I'm just going to add a little bit here, just make this one function neater, and then maybe tomorrow I'll do a little bit more. So it's very incrementally applicable. Very nice. Another advantage is that errors are going to come from the right place, because caller and related functions are going to see the right function name. Because rather than having these nested thens that are all kind of anonymous subs, you're just resuming the same function that you started with, and probably that was a named method or a named function or whatever. It has a name. So if for some reason you die, well, actually die won't print the function name, but if you croak or call some kind of function that's going to return an error message that includes the name of the function, rather than seeing all these underscore, underscore, anon, underscore, underscores everywhere, you see the right name, because it's still the same function. And possibly the biggest advantage for this implementation is that to actually write this implementation, I only had to understand the innards of Perl. Now, I say only, relatively. I did have to understand a lot of the internals, but I only had to read a bunch of .c and .h files in the Perl core source code. And they are there, they are visible, they are public, and there's only one of it. I don't have to understand anything about the C mechanisms underneath it, which means I don't have to know or care what GCC or LLVM or any of the other C compilers or the weird H+C compiler that does things that NanoBeast has no idea about. And that has a real big advantage as compared to some of the other mechanisms similar to this you may be thinking of on CPAN, because I don't care what C is doing. I only care what the Perl interpreter is doing. And there's one of it. And if the Perl interpreter ever changes, well, I can just version guard the code. I can just say, oh, well, up to 522 it did this, so I have to do this. But then later on it does something else, so I have to do something else. However, it's not quite as rosy a picture as you might have imagined so far. So currently, as of right now, you can't put an await expression inside a for each loop. That is purely because I haven't got around to writing the code yet, because it turns out what you think of as a for each loop, there's actually 5 different kinds of for each loop, because where if you say for each 1.10, what Perl actually does is just remembers the number 10 that it needs to end at, and it remembers that currently it's at number 1, and then it goes down the next time and says, actually, currently I'm at number 2, and so on. And there's lots of other little internal optimizations, which just mean that there's kind of 5 different for each loops. And so if you await inside a for each loop, I have to be able to remember all of that state to restore it back later on. So I haven't implemented that yet, just because it's lots of lines of code. I'll do it at some point. It's not hard, it's just tedious. That said, if you can happily have a for each loop inside an async function, as long as you don't put an await inside. So if you wanted to await, say, a page to arrive over HTTP, and then once the page has arrived, you can happily for each over the contents of that page, provided you don't want to await inside there. So that will work right now. I'm not how I go around to that. There's something weird with hour variables. If you have an hour variable that you reference inside the function, in certain cases it gets a bit confused. I've not quite looked into why. There's lots of innards there's lots of moving parts, and you kind of have to understand all of them. And currently local is unhandled. Yeah, this one's a hard one because all of the other languages I mentioned, C#, JavaScript, and Python, don't have a concept of local. And so none of these languages has had the problem of what does local mean inside an async function. So whereas these are just, oh, I just have to fix the implementation, the semantics are obvious. This one here is, it's unclear what the semantics mean, and I'll get onto that in a bit. And the other slight current limitation is that it requires Perl 524 for 2 reasons. Firstly, 524 is what I happen to have on my laptop. And secondly, 524 happened to be when, I forget who did it. Was it Chile? Oh, it was Dave M. So Dave M kind of completely reworked the context stack, which is this absolutely obscure internal innard that nobody in their right mind would ever want to fiddle with. Except if you wanted to suspend and resume a running function. Then you kind of have to know what the context stack is. And all of this rework made it much, much neater. So it's really nice and neat and tidy on 524, which is great. Apart from the fact that if I wanted to work 424, I have to understand how it worked before that. So that's a kind of an ongoing research task of how is this going to work. So that one doesn't quite work yet. How are we? We've got 10 minutes. This is good. So I should talk briefly about the implementation details. I shan't go into too much detail here. So most of the implementation is all about suspending and resuming a Perl function, what we call a CV internally. If any of you were in Todd's talk just previously, some of these terms might start to sound a bit familiar. So most of the logic is just about suspending and resuming a function. Primarily it does that by adding this new op called op_await, which has lots of interesting innards and is very fun. About maybe 10% of the code is actually dealing with futures, because all it has to do is understand how to ask a future, is it ready yet? If not, I will come back later. It has to be able to attach itself onto the future that it's waiting on to say, make sure to call me later. And it has to be able to handle the error unwrapping if the get fails. But other than that, there's not too much here. This really is the bulk of the work. And again, there's a small bit of logic in there to hook into the parser to actually make the thing work as a keyword. But really, this is the bulk of the logic. And at some point, what I actually want to do is extract all of the suspend resume logic into some kind of reusable piece of logic, so that if people want to suspend and resume Perl functions for other things, like actual coroutines, then that might be a useful thing. And then my module can be mainly be sort of adapting things to just wrap that logic for futures. But I'll make it work first before I make it generic. Always a good time. So how it actually works. This is the kind of the key bit. There's an internal function in Perl called clone CV, which takes a code ref, i.e. a function, and makes a copy of it. Now, clone CV is used when you have an anonymous function and you have, say, just sub something. In the actual the kind of compiled code of Perl, we have a copy of that function, which it's called a proto-sub, but it's a bit of a weird name. It's the kind of the template of how to run this piece of code. But when you actually get to that expression at runtime, it needs to make a copy of that function, because that function might have some local variables or other things in, and you want to make sure that the actual thing that runs is a copy of it, in case there are multiple other ones running elsewhere. So there's this function called clone CV. Turns out clone CV is actually quite handy for just generally copying a function. So how the suspending in await works is that we just copy the function just so that we can operate on our own local copy of it, and we're not going to screw with anyone else. We save basically as much state as we can get our hands on, and this kind of, again, is the bulk of the work and the bulk of the research is finding all of those little places in the interpreter where bits of state are. Primarily the pad, which is where all the lexical variables are. So we have our variables back again. All the block scopes that are on the context stack, so like the while loops, the for each loops, which I'm not handling yet, but I need to. The stacks, plural. Now, if anyone talks about the Perl stack, they're totally lying. I was going to write a blog post about the 4 stacks in Perl because I'd found 4 of them, and halfway through writing it, I found a 5th one. So I don't know how many stacks there are in the interpreter. There's at least 5, and a thing that looks a bit like a stack, other than that it's actually a doubly linked list. But otherwise it kind of works as a stack. And all of these stacks are custom written ones that work slightly differently, and some of them you have a pointer to the most recently pushed item, but one of them has a pointer to the next cell that you're going to fill in. And so if you don't understand that subtlety, then you'll have a whole bunch of weird off-by-one errors when you try to look at what's on the top. And there's just lots of subtle little details that obviously someone has written down somewhere. And if anyone ever meets that person, I have a list of questions for him, but nobody knows who's written that down. So that might have to be me. So yeah, you have to understand a lot of this. But other than it just being a complicated research, it's technically not hard, right? You just look at a bunch of memory, you save a copy of it, you attach a copy of that onto this newly cloned CV, so that we're working on this copy. So we've saved all of that. And then the key thing, where is Todd? So, when you compile a Perl function, the op tree, the root of the op tree, the kind of syntactic here is the outer container of the syntax, is stored in the CV in a slot called CV root, which is the start of the thing. But an optree also stores internally kind of a linked list of here is the execution order of the operations, and this is the order we're going to run them in. And the first one of those is stored in a field called CV start. So what do? I just adjust CV start of this new copy to point directly at the op await. And that's it. Because then I store that CV somewhere, and I just directly push that CV as a onReady callback on the future that I'm waiting on. And future has no idea I'm doing this. It doesn't care. So when future comes along and it says, oh yeah, this future that you were waiting on is now ready, I'll just call your function. It just calls this function, enters the Perl interpreter again. The Perl interpreter says, okay, I'm starting a new CV. Where do I go? Well, I just go to op start. And op start suddenly jumps into the middle of the op tree at my op await. And the op await wakes up and he goes, it inspects a bit of local state, and it says, I know I need to be resuming now. So all it does is it undoes all the previous steps. It says, okay, let's get the pad back, let's get all the block scopes back, let's restore the stack by first of all trashing what's on the stack. That's very important. I forgot to do that for a while and wondered why I was doing weird things. So you just kind of undo this thing, and then you carry on. And it actually works. So I wrote this. So I kind of wrote this first implementation without this middle stage here, where literally I just called clone CV, change the upstart, return it. And I was surprised that worked. Obviously, all of the things like the block state and the pad weren't working at that point because I didn't have that. But that gave me enough confidence to think this technique actually works. And then the rest of the writing the code was just making this suspend resume logic better. So when I said that, earlier that it's kind of in a very early stage of implementation, what I really mean is the future bit and the keyword bits, those will work totally fine. The only bit that's not finished yet and not working, say, back to 5.14, is this save and resume logic. And that's a really sort of low-level, it's a lot of tedious work, but it's a very useful, reusable thing that we can have.
So when you say save pad, what you're actually doing is copying the pad away, and then...
Yeah.
Because I assume you're not, like, manipulating depth.
Oh, now, okay. How long have we got? Not very long. I'll explain that later. Okay. There are so many little fine details. So what I want to do next? Well, first of all, I just need to handle these for each context. They're not hard. I need to find what the bug is with these hour variables, because some of them work, some of them don't. And I've not found any pattern to which ones do and don't work. So it's just sucking
with Kirkhoff.
No, it's something weird to do. So one of the many stacks is called the save stack, and the save stack is kind of where local and various things go. It's a bit weird and subtle, but it seems that the save stack is somehow related to our variables. I'll explain it later. And obviously I want to support older versions of Perl, because not everyone's running 5.24. Actually, most people aren't. Ideally, I want to go back as far as 5.14, because 5.14 is when the keyword, technically the keyword API itself turned up in 5.12, but there wasn't very much support from the innards of the Perl parser to ask the parser to help you implement your keyword. And a lot of the really useful things turned up in 5.14. So I would like to support this back as far as 5.14. I don't think there are any fundamental technical issues with that. It's just a matter of re-implementing the thing to work with the older version of the context stack. I want to consider the semantics of the local. It may be that I need a new keyword, because here's an example of local. And you sort of scan it through briefly, and you think, well, okay, so we have this debug variable. We set local debug equals 1. We await this first function. We print this thing if debug, we await the second function. So you kind of look through that. It's kind of fairly obvious from semantics that this print function, that this print statement must execute, because locally, $debug is 1. But inside first, what if first itself was kind of split into this, do a first thing, then await something else, then come back? Because when the second part of, when sort of the second stage of this first function wakes up again, in a sense, dynamically, we haven't re-entered this function yet. So semantically, what does it mean to have done local debug equals 1? Do we put 1 back in, or do we leave it in the state that we restored it to when we left this scope and presumably put 0 back into it? or undef rather. It's kind of, you can make arguments either way, because what the word local does is it has an effect in both dynamic scope and temporal scope, i.e. time. And that's never been a problem, because without this awaitability, those are the same thing. But suddenly when you have a wait, they're different things. And I want to do some more testing with this, with a lot of other modules. Because I do a lot of complicated things inside, I want to do a lot of other testing with the pad walkers, and also just generally a lot, basically just need more testing. So we're kind of out of time, so I'll just give you the C alsos. There's future, obviously, on CPAN. This module itself is on CPAN, it's called Async Await. I did a bunch of other talks, I've mentioned this one. The custom keywords thing has some slides, I'll put a link in there. I've got the futures advent calendar, which is all about futures. And there's the link to these slides, so you can get the rest of the links. So you may want that one. And we're kind of out of time, but we're also going into lunch. So I will say we'll stop there. And thank you.